Okay, so we're going to find the range of our square root functions. And so let's look at a basic one first. So we'll say f of x is equal to the square root of x. Now again, what is range? Range. So this is all the possible outputs of a function. And why would a function not be able to have all the numbers as outputs? Well, sometimes functions you can't have all the numbers as inputs. So when you're looking at something like a square root function, you know that there are some numbers I can't put in for x, which would probably make it impossible to get all the values for y. Now, that's not always the case, but usually it is. So if you think of a function like this one, well, what's one that we know we could plug all the numbers in? So if I say y is equal to 2x squared plus 1, this we know is a picture of a parabola that does something like this, right? And so what's going to happen here is it's going to hit all these x's, but it's only going to get so far with the y's, right? This is going to be the lowest y value you can get. So let's think about what this actually looks like if we were to graph him. He would be, the vertex would, this would be like an up 1, right? You'd move up 1 for the transformations and not left or right any. And it would be, like over 1, up 2, over 1, up 2. So it would be this graph. So this case, you can plug in all the x's, but you actually are not going to get out all the y's. So that's one case where, you're not going to get them all. And so what would the range here be? The range would be y has to be greater than or equal to, well, what was the lowest place we could get? 1. Y would have to be greater than or equal to 1. All right? But if you had something like this, you know that that's more like a function that looks like this, right? And so you're going to get all the x's and you're going to get all the y's. And so the range would be all real numbers. Okay, so you can think about these things graphically. Sometimes that's very helpful. And we'll actually look at the calculator too, in case there are some functions that you actually don't know how to imagine them graphically. Hopefully these are all ones that you know, but square root functions, right? So think about this guy as a square root function. Now, what numbers can I not plug in here? I can't plug in negatives, right? Can I plug in a 0? Sure. If I plugged in a 0, I'd get a 0. Could I plug in fractions? Sure, a quarter would give me a half, right? So I can plug in fractions. Can I plug in positive numbers? Sure. If I put in a 1, I get a 1. If I put in a 4, 1, 2, 3, 4, I get a 2, right? So this is actually what this graph looks like. So if I think about this graphically, well, we can see that the domain is x has to be greater than or equal to 0, right? And take a look. So domain means this way, right? What are the values we're going to get this way? So this one's the domain. I'm looking here. What values am I going to get as I go across this x? Oh, here I get one, but here, no, no domain. Does everyone see what we're talking about here? It's not going to touch the graph. But if I pick any of these x values, it's going to touch the graph. Okay, now range, the same thing, except what am I going to be thinking about? Now I'm going to be thinking about it this way. So where are these places touching the graph? Well, these horizontal lines are going to be touching from here to here and then, onward, because we know that even though it's going up slowly, it's going up. So our range is going to be y is greater than or equal to 0. Okay, now that's one way you could do it. You could think about it graphically. The other way you could do it is, I guess it's thinking about it graphically, but let's think about this one. Let's think about it transformationally, okay? So let's think about what this is a picture of. Well, we know this is the parent function, right? And what has this done to it? It has moved it up 5, right? So this is a picture of this. 1, 2, 3, 4, 5, and then it's, over 1, up 1, 1, 2, 3, 4, 1, 2. It's a picture of this. So you can see our domain hasn't changed, right? Because all of these guys over here I still can't use, but all of these guys are allowed. So my domain has remained x is greater than or equal to 0. But now the lowest place I'll ever be is y has to be greater than or equal to 5. Okay? Now another way you could think about it is kind of like reasoning skills, right? What's the smallest smallest value square root of x can have. So what do I mean? I mean, well, I can get a 1, I could get a 2, I could get a 15, but I can't get a negative 1, right? Because you can't get a negative number from a square root. So the smallest value this can have is, isn't that true? The smallest number I can get out of this expression is 0. Because to get a smaller one, I'd have to use negatives, and I'm not allowed. I can get bigger than 0, but I can't get smaller. So if you think about this, if this is the smallest he can ever be is a 0, and I always have to add 5 to the 0, well, then that means the smallest I can get out of this whole expression is equal to 5. Does that make sense? Since this smallest is 0. So if I'm going to add 5 to the smallest number that I can, if I add it to a 0, then it would be 5. So that would mean that my smallest output would be a 5, and that's where I would get this idea. Okay, so I got it like graphically. I kind of reasoned it out. I thought about it transformationally, so I could have looked at the picture, graphed it, looked at the picture. I could have thought about, oh, it's just a graph. I know what the picture is, and it's moved up 5. Okay, let's take a look at another one. How about this one? So once again, what's happened here? What are these 3's do to the function? These would cause a horizontal compress, and this would cause a horizontal shift. Well, horizontal changes to this picture, or to this picture, right? We'll move it around like this, or move it like this, or move it like this. But does that change the domain? I mean, does that change the range? No, right? So any numbers inside here are not going to change the range. What's going to change the range is this thing, because what does that do? This is a shift down 2. So again, what would happen, this would be a down 2, and it might shift here or here or here or here, here. But it's the lowest it's going to get is here, no matter which way, I draw it. Okay, so this is going to be a down 2. So what's going to happen is, then that means that the smallest value I'm ever going to have is y has to be greater than or equal to -2. Okay, and again, what's the smallest thing I'm going to get out of here? 0. So that means this would be a -2. If I put the smallest I could. Now, it does get a little bit tricky, however, when you have something like this. Why is that a little bit tricky? Well, now the smallest number I can get out of here is not 0, right? Because this is negative. So now we're talking about a function that's doing something else. What does this negative do to the function if you think about it transformationally? That's going to make it flip. So if I were to graph -x, hopefully everybody knows that that's actually this guy, right? A flip over the x-axis. So this would be our parent graph, and this would be our transform graph. So now 2 is actually the biggest number I can get, because I'm always going to be subtracting something other than 0. So if I put a 0 in there, it would be a 2. But if I put any other number in here, we're actually going to be making that 2 smaller. Does everyone see what I mean? So in this case, y has to be is going to be less than or equal to 2, because it's always going to be less than or equal to 2, because this graph is actually, this is -y. This one is actually -x plus 2 would be up here, and it's going to do this. So what's going to happen here is, like from 2 to 0, you'll have positive numbers if you put in like anything. If you put in, numbers that give you a 2 or whatever, you're going to get positive. But anything else is going to give you negative values, because we're going to subtract. If you subtract any, like if you put a 4 in there, you're going to get a 0. But if you put an 16 in there, you're going to get a -2, right? So, and again, if you're not sure, you can plug these into your calculator and take a look and make sure that you're thinking about it the right way. But for finding range for these, really, you're not concerned about what's going on inside. You're only concerned about these things that are happening outside, because remember, transformations that happen on the outside of the function change the y, and range talks about y. So that's why I'm not concerned about this stuff inside here, but I am concerned about this guy. I am concerned about this guy. I am concerned about this guy. Okay? So when you're looking for range, you're thinking about the stuff that's happening on the outside. Is it shifting up and down, or is it flipping over? And again, if the negative was on the inside, it would flip it this way, so that would not cause a change in the range. It would only cause a change in the domain. Okay? So see what you can do. I think you can figure it out. I don't think you'll have a problem. So go for it.